This is my lab report video for lab number 1 of Physics 2212 charge tapes. The purpose of this lab is to estimate the amount of excess charge on a U-tape through measuring the distance of levitation between two charged pieces of U-tape. And ideally, tape A and tape B will be charged with identical polarities, which will result in a repelling force between them. Here are the fundamental physical principles and model we use for this experiment. First, we use the law of gravity in conjunction with Coulomb's law. The law of gravity contains known quantities, such as the mass and the gravitational acceleration constant, and we can use these known quantities to solve for the unknown quantity in Coulomb's law, which is the charges of the tapes. For this experiment, we assume that each tape has the same net charge. This is not an unreasonable assumption because each U-tape was formed in similar matter and identical conditions, and they're both the same size. We also assume that each U-tape can be modeled as a single point charge. This is reasonable if the charges are reasonably evenly distributed along the length of the tape. And finally, we assume that there are no external forces acting, and to validate this assumption, I have done my best to eliminate any charged objects near the tape. Here's the preview of the main result of this experiment. So the suspended piece of tape was approximately 6 centimeters in length, and the separation distance was measured to be approximately 0.5 centimeters. From these values, we were able to calculate that the charge of each tape is approximately 1.278 times 10 to the negative 9th power, and from this, we're able to calculate that the amount of electrons in each piece of tape is approximately 7.988 times 10 to the 9th. Here is a figure describing the premise of this experiment. We have two pieces of tape which are negatively charged, and as like charges repel, the repulsion force causes the static tape, which is the tape on the bottom, to push the non-static tape up. The top piece of tape is kept suspended in equilibrium by the electric force, which pushes it upwards, and the force of gravity, which pulls it downwards. Here is the very primitive setup I created for this experiment in my room. So we have the two pieces of tape which are held in place by a few plastic bottles and other random objects. Then we measure that the length of the tape is 6 centimeters and the separation distance is 0.5 centimeters. Furthermore, the fan was turned off in my room and the window was closed to eliminate any external disturbances that may skew the results of the experiment. The initial conditions of this system are as follows. We have two pieces of Scotch tape that are clear, that are initially neutral to begin with, and a third piece of tape fixed to my desk, which is used to charge the other two tapes. The system includes the two pieces of tape and the earth, as the force of gravity is involved. Here are the steps to perform the experiment. First, we have both pieces of tape which are initially neutral. Each piece of tape is individually taped to the base tape on my desk, and then swiftly removed from the base tape. This process is repeated for the other tape, and once we do that, we place one piece of tape on a set of plastic bottles, and the other piece of tape under that piece of tape, and we push that piece of tape upwards until the tape on top slightly levitates. Then finally, we take a photo, and the levitation distance is measured in reference to other objects in the scene. Here is the computational summary before I get into the actual math itself. Here are the given quantities. We're able to measure that the distance between the two tapes are 0.5 centimeters. The length of each tape is 6 centimeters, and the acceleration due to gravity we will take as 9.8 meters per second squared. From this, we were able to calculate the mass of the tape, assuming that 1 meter of tape is 1 gram. And also from that, we're able to calculate the gravitational force. Finally, we infer that the electric force is equal to the gravitational force as the system is in static equilibrium. So here we have the actual computation being performed. This is the equation we use to find the charge of the tape. This is how we find the mass of the tape. And then we solve using these given quantities for the charge of the tape, which we find to be about 1.278 times 10 to the 9th coulombs. And we can just divide that by the charge of an electron to find the number of electrons that are on each tape. We can calculate the ratio of electrons to atoms as follows. We know that the width of the sticky tape is 2 centimeters, and the area of the sticky tape is then the length of the sticky tape, 6 centimeters, times the width of the sticky tape. We also know that the number of atoms is going to be equal to the area of the sticky tape divided by the area of an atom, which is 1 times 10 to the negative 10th power squared. From this, we can then find the ratio of electrons to atoms because we know that the number of electrons from our previous slide. So we divide the number of atoms by the number of electrons, and we get that we have 1 electron for every 1.502 times 10 to the 7 atoms. Here is the coding result. So we have all these constants, and the charge is found as the gravitational force divided by 1 over 4 pi epsilon null times the distance squared, and we take the square root of all of that. And then the green arrow here in this diagram represents the electric force acting upwards, and the orange arrow represents the gravitational force acting downwards, and of course the blue sphere on top is the top tape, and the blue sphere on bottom is the bottom tape. Similar assumptions are made for the coding, and we assume that air resistance is ignored and not modeled in the program. We also treat both pieces of tape as a point charge with all the charge concentrated in the center, and we also assume that both pieces of tape have the exact same charge. And we got the exact same magnitude of charge using this. So there are a few differences between the theory of this experiment and the actual empirical results of the experiment itself. First of all, similarities. We know the magnitude of the electric force must equal the magnitude of the gravitational force for the tape to be suspended. And we also know that both pieces of tape are negatively charged, or rather charged with the same polarity, which allows for a repulsive force. There are some differences, however. First of all, the charges of the tapes may not necessarily be equal, as some tapes could lose charges during the process. And also, other objects in the scene could have an effect. For example, the tape could have been attracted to the plastic bottles, which would disturb the results of the experiment. Finally, there are other sources of error that are present. First of all, measurement error. I may have measured the length of the tape or the separation distance incorrectly. There's also human error, which is touching the tapes could cause one of the tapes to lose more charges than the other. And finally, there's also external error, such as environmental factors as wind or extraneous charges on other objects, which could affect the separation distance. What if the electrons had positive charge and protons had negative charge? This would actually make no difference because all the other observations would be identical, and it would still be the case that electrons are attracted to protons, and electrons and protons repel each other. Coulomb's law still holds, and the results of the experiment would be exactly the same. And it's important to handle the charged tapes as little as possible, because when the charged tapes come into contact with other objects, electrons will transfer from the tapes to the uncharged objects in an effort to balance the charges between the two objects, which will decrease the overall charge of the tapes. And therefore, it's important to ensure that the charges stay isolated on the tapes, otherwise the effect of the tapes may be diminished or unnoticeable.